Okay, so today we're going to cover even function, odd function, and then we're going to cover the other 4 functions which are on the basic one list. Okay, so go back to the concept which is on the second page of your notes, right? On that page, we mentioned the definition of even function. Even function and odd function. I believe that some of you probably have, know this concept, but this concept, it's pretty important. You guys will encounter these concepts in calculus classes, again, under the calculus setting, okay? In particular, I would say in chapter 5, it could be as early as chapter 5 in calculus 1 and later on. So it's worth going over this concept. So we're going to spend some time, and also at the same time, we're going to review some of the basic skills that involved in these operations. All right, so what's the definition of even function? Even function, of course we know that it has to be a function from the start, right? So we have a function here, right? So if the function, okay, well, we have f of negative x is equals to f of x. Okay, for any x in the domain of f, then we will say f is an even function. Okay, the next definition, of course, is odd function. Odd function, just, in the definition, I'm just going to copy and paste and make some critical changes, right? It's an odd function. It's a odd function. So that's the definition of even function, odd function. So you may like to put these 2 concepts on a flashcard. So we're going to explain to you what it means. Okay, what it means. So there's several aspects about this. Right? First of all, we know a function is a rule. So what does this mean? Right? So take the even function, for example, right? In these expressions, so let me put just make it larger fonts, right? In these function, in these expressions, what it means, right? Meaning. Right. So we're gonna look at the different aspect about these definitions. Okay, the algebraic, the visual, the numerical, right? What's the difference between the negative sign inside the parentheses or outside the parentheses? Right? Do they mean the same thing? Well, we know f of x, right, as a function, right, is a rule, right? And this function will take an input. Each input, it produces exactly 1 output. That's the function concept. Then what is f of negative x, right? So this is f of x. The first one is f of x, right? That's the operation. Right? You view this as a machine, and we have input, the rule applies to the input and produces exactly 1 output. How about negative? And when the the negative sign is inside. What happens is that before we get to apply the rule function, so we first process the negative, the opposite of the input. So you choose your input, X, right? And then you take the opposite of the selected input. And then the opposite of the input is going to be apply the rule. So the rule of the function apply to the opposite of the input. So that's the meaning. How about a negative of f of x? Negative of f of x is basically saying, okay, I'm going to take an input and I get the output, right? So I'm going to process f of x first, and then I'm going to get the negative, get the opposite of the output. You see the difference? So f of negative x means the input is negated. Okay, the opposite of the input. And the other one is the opposite of the output for the same input. Then you say, are they the same? Are they not? Well, sometimes they're not. Sometimes they're the same. Sometimes there's a sameness, right? And sometimes they're all kinds of situations. They're all kinds of situations. But you can see the order of operation is much reflected in the notation. It's much reflected in notation. So let's look at some examples. Okay, let's look at some examples. Okay, let's take a simple example. F of x equals to x squared. Okay, f of x equals to x squared. Right? So how do we assess? Of course, we know the domain. And we even know the graph. What's the domain? And what's the range? And what's the graph? Do we know the graph? Right? When we look at this function, I believe everybody knows the graph, right? We did this graph some time ago. Right? We do the graph some time ago. And in terms of even odd concept, right? How does this visual being observed, right? We know the domain is all real numbers, right? Domain is all real numbers. So yes.
We have a chat.
Very good. What does it mean for x? What does it mean? It means, oh, this notation. It's not an E. It means it belongs to, part of, or one of it. Okay, so this notation means in. Okay, it means in. So x is in the domain of f. So you basically chose a number in the domain. Okay. All right, any other questions? So here I can say x, belongs to. So x is in that interval. Okay, x is in, x is from, selected from. All right. So this is the function. Now let's look at what is f of. Okay, from this interpretation, right? These are illustrating the process, right? In this particular example, when x squared as a concrete function, what does it mean? Right? Suppose that now this is going to be x squared. This is going to be x squared. Okay, what is the negative of f of x means? Well, this is going to be x squared. Right, this is going to be x squared. So when you then you put a negative sign in front of x, f of x, that's going to be negative x squared. Okay, f of a negative x is that you take the input x and then you have the negative, then you find the opposite of x. And then after this function, what are we getting? We're getting negative x to the power 2. You guys see the difference? You guys see the difference? So when you find the opposite of the input versus you find the opposite of the output, the consequential output may or may not be the same. In this case, they're not always the same. For example, negative x squared, what would that be? It's negative 1 squared multiply x squared. Negative 1 squared is always 1. So it's going to be equals to x squared. So f of a negative x is going to be equals to, in fact, it equals to f of x. Right? Because our f of x in this case is x squared. So this is actually an even function by definition, because this is true for any x in the domain. For any x in the domain. So we have just proved, right? Then you say, well, to prove this function is even, do I have to write so much? No. Okay. So let me give you a former proof, right? Which is pretty straightforward, right? So we want to prove that f of x equals to x squared. And I believe some of you would know, you know this, we just review this quickly. It's an even function, right? So how do you prove it? How do you prove it? This is how you prove it, right? So what you do, you don't need to draw this machine and so on and so forth. All you have to do, you just start with f of a negative x, right? And that equals to all of these, right? So you just demonstrated f of a negative x is equals to f of x, right? So that is f of a negative x equals to f of x. And we know that this is true, right? This is true for any number in the domain, because that's what it says, in the domain of f. Then you say thus, the function is an even function. And the proof. And the proof, you can make it longer, you can make it shorter, but essentially that's what it is. Okay. Now, let's look at the details. Let's look at the details. Okay. So mathematically, as we explain this, you know, this input output thing, when we actually write it mathematically, we just use the shorthand notation. We just use the shorthand notation. Now, let's see what it really means, right? So let's look at some examples about the implication, and then we're going to look at the graph. Okay, so we're going to look at some examples. And I want you guys to get involved in this process, okay? To get involved in this process, okay? So I have the input, right? I have a negative x. And then I'm going to have you guys calculate f of x and f of a negative x. Okay, I'm going to give you some specific numbers. So for example, I'm going to give you -2. I'm going to give you 3. And I'm going to give you -1. I'm going to give you a 5, maybe a -4. Okay. And your task is to calculate negative, the opposite of x, the opposite of x. And then, of course, I'm going to give you another column. Okay, so in this exercise, you are exercising using the notation correctly, at the same time understand the concept of even function, odd function, and also reflecting on the process, on the flow, okay, or the, reflecting on the flow. So I'm going to give you an example as how to do it. Okay, so let's look at that example. And here our function is just f of x equals to x squared. Okay, so if x is -2, what is negative x? Negative x and x are opposite numbers. They're opposite numbers. So when you put a negative sign in front of x, you get an opposite of x. And that x itself may be negative, may be positive. Okay, so negative of -2 is +2. Right? So some of our students, when they see x, when they see negative x, they tend to assume that x is going to be positive, negative x is going to be negative. No, that's not necessarily. X could be negative itself. So negative x could be positive. For example, in the case that I introduced to you at the beginning of the semester, okay, why do I introduce this at the beginning of the semester? Because I expect you guys to really understand this, to really understand this for the remainder of the time before you take calculus, because that might be how much time you need to understand this. Sometimes some students understand it on Sunday or on Monday, and on Wednesday they get confused again. And later, we're going to talk about the variations of this work, because you get to see their variations. You're not going to see exactly the same thing, right? You're not going to see exactly the same thing. You will see exactly the same thing sometimes, but sometimes you get to see the, this function dressed up. Right? We spend much time on this in class, and there's a recording on the first week. Why do you think we did it on the first week? This is the number one trap. People make mistakes, and how many points do they lose? 20, 30 points. And you cannot go about calculus to ace your calculus without having to deal with this function, period. Okay. Among all the textbooks I have seen personally, okay, the textbook in Japanese, Mandarin Chinese, English, French, German, even though I don't know much of that language, they all have to deal with this example, critical example in calculus. Calculus 1, calculus 2, probably calculus 3. It's that important. So do you really understand this stuff, right? So the hardship of this expression is that when people see the negative sign, they say, oh, don't you say that the absolute value of a number is always a positive? How come you get a negative sign there? When x itself is negative, the only way to do the absolute value is to put a negative sign in front of a negative number. So this consequence is going to be a positive when x is less than 0. Okay, and that turned out to be one of the hardest things for a lot of our students. But by the time if you don't get this, you're in calculus class, you just lose points left and right. Quizzes after quiz, exam after exam, and on the final exam, they're going to show up somehow, somewhere. I promise you. Okay, so these examples I put in here, okay, just to demonstrate x is not a negative, not necessarily positive. Negative x is not necessarily negative. X can represent any real number. It could be positive, negative, 0. Okay, so now let's work through this. What is f of x? Okay, this is absolutely basic skill, absolutely basic skill. The kind of basic skill you will need for your future classes. So let's do it. So f of x means what? F of negative 2, that's negative 2. So x will be replaced by negative 2. And what is negative 2 squared? Negative 2 squared is negative 2 times negative 2. It's equals to positive 4. And what is f of negative x? If this is f of x, f of negative x, that x will be replaced by negative x. Right? But now your negative x is a 2. So this is going to be 2. And that's going to be 2. And 2 squared is 4. Okay. And the last column, okay, we're going to compare f of negative 2 with f of 2. What is f of 2? What's their relationship? What's their relationship, right? F of negative 2 is 4, f of 2 is also 4. They're equal in this case. You see, we get to use the notation a lot. We get to use the notation a lot. Okay, now, this process we just did, if we take this process into the picture, what does that mean? Okay, we just graphed that curve, didn't we? Where's my curve? Right here. What does that mean? What does it mean f of negative 2 is the same as f of 2? What does it mean? Negative 2 and positive 2, these two numbers are opposite, but they're inputs. Okay, but these two inputs are opposite to each other. So how do we find inputs? Right? Inputs. Inputs are horizontal measurement from the same point of reference, right? So if this is a negative 2, measure from the same place, that's a negative 2, right? What is a positive 2? Positive 2 is also measured from the same place. And what will be the output? The output for negative 2 is this much. That's the visual. That's the visual. The output for positive 2 is this much on the curve. And what does this expression tell us? This expression tells us when the input is negative 2 positive and a positive 2, 2 and negative 2 are opposite, their respective output are the same. The true red of the same height on the same size. They're both positive. That's what it means. So this is the algebraic, and that's the picture. Do you guys follow me? Do you guys follow me? Now, with this example and this understanding, you're going to do the rest of the table. You're going to do the rest of the table, please. Okay, so you're going to work out the 3, negative 1, 5, negative 4, for all of them. You work out them the same way. I'm going to set up a breakout rooms if you want to go with the Farouz. If Farouz is here.
Yes, I'm here, Professor.
So breakout rooms, self-designated, open all rooms. Okay, so go for it. Okay, I want you guys to use the notation. Use the notation. reflecting on the notation in the context of input output. Okay. Get ready to go. Ready, set, go. Okay. From algebraic operation, numerical calculation to the graph, what it means. Enhance understanding. Okay, it looks like some people already went there. Okay, get your paper, pencil, and work it out. Work it out. Okay, so if you stay in my room, I'm gonna leave you guys to work independently just for a couple minutes. Okay, just for a couple minutes. And then I will catch up with you. Just follow my example. Just follow my example, okay? To understand the notation. Insert a row here. How's it? How are you guys doing?
Doing well.
Good. I'm also trying to introduce some useful notations that you guys going to need in the future. You know, a lot of us just need time to really understand this notation. But once you understand it, really, it's just not a problem anymore.
We are back, Professor.
Wonderful. Thank you. Good job. I'm trying to introduce some notations you guys are going to see in your future settings so you won't get so confused, right? Do you guys see the picture? I tried to put these pictures on one on one graph using one software, because otherwise it's going to be awfully confusing, right? Because if I move, the two software don't talk to each other. They don't talk to each other, right? Okay, so did you get the algebraic part of it? Did you guys get the algebraic part of it? The algebraic part, which is these are examples, just show you what it really means, right? The negative sign inside, the negative sign outside, right? Big difference, right? Big difference. Now, oh wait, I need to make some corrections here. This is a negative and -3. Okay, so I basically have done the same. I have done it for 2. I didn't introduce those as, special notations. And these are notations, as you can see, are pretty self-explanatory. But if you have never seen it, right, and your calculus class professor will suddenly, will start using them, it's going to take you, you're going to be taken aback. I said, what does that mean? Well, it's actually pretty self-explanatory. Here, you can see the blue. The blue tells you there's a positive 3 as the input, the negative 3 as the input. And their output are respectively f of -3 and f of 3. See here, I didn't put a 9 there. Did you see? I didn't put a 9 there. Yes, they're equals to 9. But they're also f of -3 is also 9 is also f of -3. Do you guys see that? F of -3 is the same as 9. Okay, so now you will have, so you will see that this little dot here, the input is 3, the output is f of 3. This kind of notation is very commonly used. For example, typically you will see your professor using these notations. Okay, I'm going to show you. They will put a point, you will put an x here, f of x next to it, right? And they're going to put it where? I'm going to put it like 320 or something like that. Okay, so 3, 15, right? And this will represent an arbitrary point on the curve. An arbitrary point on the curve. Say a point like this. Instead of putting x comma y, they put f comma f of x. Have you seen that before? I mean the same thing, x is the input, f of x is the output. They mean the same thing. They mean the same thing, often used, commonly used in the future courses you're taking. Okay, so that was just on the notation side, And I will be using these notations from time to time, not all of them, just here and there, because I want to train you guys to get ready for these notations. Okay, these are very, very basic notations. Okay, so without further ado, so have you guys finished for -1, right? So this is going to be negative of -1. Now I'm behind you, right? I'm behind you. So f of x, right? F of x, x equals to -1. Are you guys doing well with this? You think you're good at these notations now? Do you think you're good at these notations now?
Yes.
Good. It has become easier and easier, right? So negative x is 1, so that's going to be equals to 1 squared. And that is the intention. So having the answers is not as important as understanding the process. Okay. I see lots of yeses, right? You're getting used to it, right? You get into the mode, you know, very good. And so over here you get f of -1 equals to f of 1. So what do we conclude here for this function? What do you observe? When the inputs are opposite to each other, what happened to the output? What happened to the output?
Professor, can you repeat the question, please?
When the inputs are opposite to each other, whenever the inputs are opposites, what happened? Their respective outputs are what? When the inputs are opposite to each other, right? The inputs are opposite numbers, -2, -2, -3, 3, -1, 1. The inputs are opposite. What happened to their outputs?
Their outputs are the same.
That's right, are the same. Isn't that true for every input in the domain for this particular function? So you can see those words translated into picture. Right? Do you guys see that?
And the table.
On the table. You need to understand all of these. You need to understand all of these. And the notation. Right? So now let's do, -5. Do I need to complete this? You guys already did it, right? Can I just move on?
Professor, I had a question.
Go ahead.
For the final column, does it really matter in which way you arrange these two? Like f of -1 equals 1, can you just say f of 1 equals f of 1? -1, sorry.
Sure, no problem. You actually can also write it this way. You can also write it as f of -1. Okay? It doesn't matter which order you write it. They're saying the same thing because if left is the same as right, right is the same as left, right? It doesn't matter which one you put on which side. But it has to fit some, because all of these we do here is to enhance understanding. Understanding means you have to be able to express it, to apply it. Does that make sense? Not just a bunch of symbols, putting together, you don't know what it means. If you don't know what it means, they're junk to you. They're junk to you. Okay, so f of 5, of course we know 25. So I'm going to just speed up a little bit. Okay, so f of -5 here, I'm going to expedite this, right? So that's just -5, -5. So that equals to 25. I put the comments underneath it. But that's really the other way to say the function is even. It's another way to say the definition. Whenever the inputs are opposites, their respective outputs are the same. That's the essence of even function. Whenever. Where else did we hear about whenever? If you look at the definition on the second page of the notes, where else did it say whenever? We said that for one-to-one function, didn't we? We said that for increasing function, didn't we? We said that for decreasing function, didn't we? Did we?
Yes.
Okay, so, well, these are the methods you're going to have to study your calculus classes, right? Every word count. You have to think about the meanings of those words. Okay, so when we have f of -4, so let me just put these things here for your check. Anybody has any questions? Right? And you observe all these, I would say, anecdotes, and then you realize, oh, they all have the same pattern. Okay, so f of 4 equals to 16. So I'm just going to get there quickly. Okay, so you can also write it this way, right? F of -4 is equals to f of -4, and I put a negative sign outside of the parentheses. Why someone would write it this way? Why would someone write it this way?
Is it because the f negative parentheses -4 is positive?
That's right, because we're trying to be fitting to the definition. This is when someone write it this way, which is not uncommon. Someone is trying to quote the definition. Okay, someone tried to quote the definition of even functions, right? I'm sorry, just let me grab this, right? So why do I write it that way? Is it negative of -4 is 4? Yes. But why would someone write it that way? Because when x is -4, that's what it is. It's quoting the definition. So sometimes, you see some people write their work in a certain way because that reflects their thoughts. What is being quoted for their steps? What's being reflected in the process? Okay, so when you're in calculus class, you constantly have to reflect on what the definition of limit, what the definition of continuity, differentiability, and all of that thing. Every single time you put in work on paper, you need to reflect on those meanings. And you need to dig deep and deeper yet to make an A. That's really what you need to do. So the transition between algebra to calculus is a hard one. I've been through it, right? And I'm just sharing my experience with you. Do algebra, you can do it, a lot of you probably can do it on the fly, but not with calculus. That's not enough. Okay, But anyway, without further ado, so we observe that this pattern is true for what? With this particular function, f of a negative x, right, is true. But this is not a proof, okay? Don't get me wrong. This is not a proof. This is just, verifying. So this is true for any number in the domain, positive number, negative number. I've selected some positive number, some negative number. I did not select 0 because 0, when x equals 0, the case is too trivial. So I didn't put them there, okay? So this exercise, I put it here. I also have another purpose for you guys, as I just mentioned earlier, okay? A lot of our students, not just you, a lot of our students, including those students I've taught in calculus class, they look at x, they only see positive number. No, x can be negative itself. Without that realization, you cannot understand this piece. And then you're going to lose 5, 10 points, 20 points, 30 points. Guaranteed, guaranteed. Okay? Because x is a symbol, it's a placeholder. It's a placeholder. Okay, so that's the first example. That's the first example. You can see from algebra expression, from definition, and what can be derived, right? So let's look at another example. Okay, so this is the summary. This is the summary about what we observed about even function, right? Even function. Okay, of course, after this, we're going to get to our trig functions, right? We're going to get to our trig functions. Okay, so the next example we're going to do is that we're going to look at this function. This function is also very, very important function. You're going to actually see this function being used in calculus class, right? So we did the graph. And now let's look at this function in the context of even function, odd function. Okay, in the context of even function, odd function. Okay, we understand the process, right? So now I want you guys to do another table. Okay, some columns, right? And we're going to work with this function. We're going to work with this function. And, f of negative x, right? And then you're going to do, we're going to put it here, right? So we're going to have x, we're going to have a negative x, and we're going to do the comparison. Right? So once again, I'm going to give you a couple numbers, right? -3. I'm going to give you a fraction. How about that? Right? A negative fraction to practice you. So you guys get to practice your fraction. I'm thinking even give you some radicals. Not this time. So just like that. Okay. So for this function, you're going to see that if I choose my input to be -1, right? Negative of -1 would be its opposite, right? So to get an opposite of any number, you just put a negative sign in front of it. So x, negative x, they're always opposite to each other. But x itself can be negative, positive, 0, right? So negative or -1 is +1. So what I want you guys to do, okay, also reflective on the process, okay, also reflective on this process, right? So we have x, right? And the function, which is f. Very soon in your in your learning experience, in your calculus classes, you're not going to see people drawing these things for you. Your professor won't have time to do it. I'm doing it because I want to instill that concept in you. Okay, I want to instill that concept in you. Okay, I'm going to lead you to the door of calculus so you have a fuller idea about what function is. Okay, and this other one, of course, you're going to have x, and then you have a negative x, and then you're going to get the opposite, and then apply the rule of the function, right? And then you're going to have f of a negative x. So that's the process we're working with. And for this function particularly, when we have f of x equals to x to the power 3, when the input is -1, right? This is a -1. -1 raised to the power 3 is -1 time itself 3 times equals -1. So f of, because negative x, well, x is -1, negative x is +1. So f of 1 is equals to 1 to the power 3. Okay, so that's going to be equals to 1. Okay, so now we're going to do the comparison. What happens, right? When the input are opposite to each other, what happened to the output? So we're going to do, so as you're doing this table, okay, so I'm going to want you guys to observe what you see. Whenever, so I'm going to give you some hint. Whenever the inputs are opposite, their respective outputs are, so you're going to put the words there. Okay, so we're going to have the breakout room. We're going to open all the rooms. Okay, we're going to open all the rooms. Okay, if you want to stay in my room, great. If you want to, go with Farouz's room, great. Okay, but I want you guys to carry out these operations. At the same time, you reflect on the input output, and maybe you grab the pictures, right? You grab the pictures of this function. So I'm going to work on that picture. Okay, and you guys just work on that table. Okay, so I'm going to work on that. Did you guys get the table? Did everybody get the table? You know what to do? Yes? Should I keep it a little longer there? All right. Bruce, did you write down the table? The table? Did everybody have the table? Because I'm just going to mark a few points on the graph and show it to you. Okay, so you work on the algebraic. Nobody said anything, so I assume everybody's good. Oh. How are you guys doing?
I'm doing well.
Good. Am I going too slow?
No, I think it's an okay pace.
Okay. I don't want to get you guys so bored.
We are back, Professor.
Wonderful. How did it go? Did we
Very
get the
well.
algebra?
Very
Sorry?
well. Very
Very
well.
good.
Very well.
Did we understand the algebraic part of it and did we understand the algebraic part, right? So from the algebraic part, you guys can handle it, right? Yeah. Very good. I'm glad to hear that. So I'm just trying to get these numbers. I want to show you these notations like commonly used.
So, Professor, activity was very well because in the 6th week of the semester, finally we build up confidence and we are following. You keep asking us, use those, terminology, make the connection between the definition and all those things. So in the 6th week, this is the first day of 6th week. And I see very, very high level of confidence from the students in breakout room.
Oh, I'm glad to hear. Thank you.
You're welcome.
All right. Thank you for your feedback. Okay. I was asking about the pace. Sometimes I was a little worried that it might be too fast, too slow. So I kind of check on you guys. So please let me know, right? Too fast, too slow, too fast, let me slow down, too slow, I will speed up. Okay, so I put some notations here for the case of -3 and +3, right? You guys already work out the number. So we're now doing the visual, right? We're doing the visual. So as you go through the process, what did you see? Whenever the inputs are opposite, did you guys fill into that blank? Whenever the inputs are opposite, what happened to the outputs? Their respective outputs are
Also
what?
opposite.
They're opposite too. Very good. Okay, that's what we observe. That's basically another way to say a function is odd. Okay, this function you actually will use in calculus class. So visually, right? You see the inputs are opposite, which are the blue, right? The blue are measured from the same place as we always talk about, right? The output also measured from the same point of reference is vertical. And whenever the inputs are opposites, their respective outputs are opposite as well. That's what we saw, right? And this is not only true for the pair of inputs 3, -3, it's true for any inputs, So that's essentially the odd function. And what is more, algebraically, how do we express it? Right? Whenever the inputs are opposite, right? Their respective output. Okay, so this is the output for the input of -1. And the other one is that what? F of 1, right? The input are opposite, inputs are opposite, the output are opposite. So if we put a negative sign in front of one of the outputs and we get the other, that's how we express that fact. Whenever the inputs are opposite, their respective outputs are opposite as well. Don't you think that's pretty neat? Agree? That's how we express it. That's what you have just observed, right? You just observed. So for 2, the opposite is -2. And of course, you guys are getting f of 2 equals to what? Equals to 8. What is f of -2? Equals to -8. So whenever the inputs are opposite, their respective outputs are opposite as well. So how do we express that relationship? Well, because the 2 numbers are opposite to each other, you put a negative sign on one of them, you get the other. That's what opposite means, right? And that's how we express them algebraically. Okay, you're gonna put the negative sign in front of one of them, and you get the other. Okay, so what does it mean if we put a negative sign in front of it in the graph? If this is the input, right? If this is the input 2, the output is 8. I'm sorry, the input is 3, the output is 27. What's the opposite of 27? So this piece, right? This piece, the opposite of it is going to be the yellow. Do you guys see that's yellow? Right? So that piece is the opposite of f of 3. I'm sorry, this is too light. Okay, this is too light. I'm going to change to a different color. Right? So this is is negative. Okay, this is a negative of f of a -3. Do you guys see that? And now the green and this red are the same. That's the visual. That's the visual. Do you guys follow me? Yes? Now, how about the other one? If I put a negative sign in front of this output f of -3, what would that be?
Positive.
That's right. And visually, it's going to be like this, right? The opposite of f of -3, what would that be? The visual would be negative of f of -3. Do you guys see that? The opposite of f of -3, you just put a negative sign out of it. And it's vertical because they are output, vertical measurement. So this green is the same as this red. And this green, and this red is the same as this green. You put negative sign in front of it. That's the visual. That's the kind of visual it creates. Did I make myself clear?
Yes.
Okay. And then we realize this is true for every point if the function is odd. And you have done all those points. I'm very proud of you. It's a tedious work, right? Soon enough, you realize, oh, this work is tedious. But if you put your observing eyes in the process, you start to understand what it really means, right? What it really means. Yes? Any questions so far? Okay, in the process, along the way, I also have introduced some of these notations. You see, instead of putting 3, 27, I put a 3, f of 3. instead of putting -3 comma -27, I put a -3 f of comma -3, f of -3. Why do I do that? Because you're going to see these notations in calculus. Sometimes you see a notation, your professor expects you to know, you don't know. You just look at that lecture, what do? You got stuck there. And the lecture goes on. You guys follow me? Does that happen to you? I hope it never happened to you. It happened to me. It did. Right? Because you got stuck somewhere, you don't know what that darn thing is. Right? What is that stuff? Right? So even, odd. So let's finish proving that this function is odd function. Okay, so we're going to prove, I'll give you a break. Okay, prove that this function is odd function. Is odd. Okay, the proof is very straightforward. Okay, the proof you just start with, right? Negative of x with all the exercise you've done, but your proof has to make sure your input can be any input. So that equals to -1 to the power of 3, x raised to the power of 3, -1 to the power of 3 is -1, right? And x raised to the power of 3 is x raised to the power of 3. So this is going to be equals to negative x3. And that's just going to be negative of f of x. And this is true for what? For any real number x. And any real number x, of course, is a domain of f of x. And then you can say thus, f of x is odd. Okay, so it's a fitting. Okay, the description. So the whole thing I'm doing here is just to quote the definition. Just to quote the definition. Okay, and we have done we see how to prove it, right? And we saw what is the visual and what are the point examples, right? Do you guys want me to complete this table in class or you're fine? You got it.
Could you maybe do the fraction one?
Okay. So the opposite of negative 2/3, right, is negative of negative 2/3 equals to 2/3, right? And then we're going to apply this function rule to the input of negative 2/3. Oops, what am I doing here? Right, so this is the input. So we put that input in here and replace x by the inputs. And of course, you're going to multiply these three numbers. You're going to multiply these numbers 3 times. So in the end, you're going to get a negative, right? 8 over 27. Okay. And f of 2/3, f of 2/3. And that's just going to be equals to 8 over 27. It's a positive number. Okay. So I'm going to give you a break for 6 minutes. Okay, come back at 12:40. Well, today's class will last until 1:20. Okay, on 1:20. And I'm not taking a break. I'm just going to complete the table for you. Okay, so you guys can go ahead and have a break and come back at 12:40. Would that be okay?
Yeah, Professor, can you go down to the proof for the x3, x cubed?
Sure. Sorry. Oh,
I took a picture, so thank you.
oh, no worries, you got it. Okay. So I'm just going to complete this table for you, just in case you guys, you know, the whole process is to try to get the notation, the understanding in place. It's not about simply get the answer. It's not about simply getting the answer, okay? So we want you to be reflecting on this process and the notation, right? All right, so we just introduced the even function, odd function. Then we know what it means, right? The algebraic, the graph, right? The features. Then the next question is every function even or odd? Or are there functions that's neither? Could there be a function that can be both? Right? So all of these questions are possible. Can a function be both even and odd at the same time? I want you guys to think about that question. Can a function be even and odd at the same time? If that's true, what will happen? Is every function has to be even or odd? Are there functions that's neither? Right, so we have the definition of even odd function. So I'm going to give you an example. F of x equals to x squared plus x. Is this function even? Is this function odd? Is this function both? Is this function neither? Right? How do we decide a function is even or odd? Well, by definition, That's the most straightforward way to do it. The algebraic way actually is the easiest way to do it. It's the easiest way to do it. Okay, so I'm going to show you a standard way to do it. Okay, for example, we will start because we don't know it's even or odd, right? So we know that we need to observe f of negative x and compare with f of x, right? You can see from the definition, what do we need to do is that because we don't know which one is true, maybe both are true, maybe neither is true, right? Who knows? We don't know. But one thing is certain, we need to know what is f of negative x. And we also need to know what is f of x, negative of f of x, right? So we're going to work that algebraically. So in this case, I will put f of, because I already know what is f of x, right? So I will get f of a negative x. The domain is all real numbers. That's not a problem, right? So f of negative x, right? According to this rule of the function, f of negative x is going to be negative x squared plus negative x. And then what do we get? Negative x squared is going to be negative x times negative x. Negative x times negative x. Plus negative x, that's just going to be minus x. Right? Negative x times negative x is going to be x squared because negative times negative is x, it's positive 1. So it's going to be x squared minus x. So that's f of negative x. And then you compare these two. Compare f of x with f of negative x we just found. Are they the same? Are they the same? One is x squared plus x, the other one is x squared minus x. So they're not the same. Not the same means what? Thus, f of x equals to x squared. This particular function is not even. It's not even. Now the next question is it odd? In order to get it even, in order to know if it's odd or not, we have to compare what? We have to look at the definition. What do we compare? Now we know it's not even, right? To whether or not they're odd, we need to compare f of negative x with a negative of f of x. Do we have a negative f of x? Well, we have f of x. We have f of x, all right. So what is a negative f of x? So you put a negative sign in front of it, in front of the output. And that's going to be negative x squared minus x. And we're going to compare, we're going to continue the comparison. So we compare what? We compare f of negative x with what? With what? With the negative of f of x. Because that's what's said in the definition, right? Are they the same? Are they the same? Obviously not, right? This is f of negative x, it's x squared minus x. And this is a negative f of x, it's a negative x squared minus x, right? So obviously they're not the same. Therefore, this function is not odd. So we have a function that's neither even nor odd. So what do we say? Conclusion. Okay, this function is neither even nor odd. So look at all the functions we have. Some may be even, some may be odd, some might be neither. Okay. All right. Do you think you want to see if there's a function that's both?
Yes.
All right. We can certainly ask that question, right?
They're both over a different domain.
No, they will have the same domain, right? So suppose that we have a function that's both even and odd. Okay, so let us phrase this question, right? Let us phrase this question. Is there a function that is both even and odd? We don't know. So
It's
let's
where-
suppose, I'm sorry?
Would it be where f of x is equal to negative f of x?
That's right. So the two definitions are both satisfied. The requirement, that's a good start. Okay, so suppose, right? That's a good start. Not only that is true, both are true. Okay, so let's suppose we have a function is both even and odd. What does that mean? i.e., both are true. Both are true. If both are true, what can we do about it? What can we do about it? This is true and that is true. What can we do about it? Can we add these two on both sides? And what do we get? If I add the left with left, the right with right, what do I get? Of course, X must be in the domain, right? In this case, you know, it's in the domain of F. We don't know what this function is, right? But we know that if both conditions are satisfied, I can do something about it. So I can add the left with left, the right with right. What do I get? I will get 2 times f of a negative x equals to 0. If I divide both sides by 2, f of a negative x is 0. What does that tell you? This tells you, right? This has to be true. Remember, this is true for any x. For any x in domain. And what does that tell you? That also tells you, okay, I can manipulate in some other ways too, okay? I can also manipulate this way, okay? From here, because I want you to see this better. From this guy, I can multiply both sides by the negative sign, right? So this will be the negative sign and this will be the positive sign, right? So if I add these two, I will get 2 times f of x equals 0. Do you guys follow me? It's a minor algebraic change, but make you see better. You follow me? So I bring this negative sign to the other side. So I get f of x equals 0. What does this tell you? The only function that is both even or odd, is both even and odd, is this function. 0. F of x is a constant function. Not only it's not any constant, it's 0. Okay, so f of x equals to 0 is the only function that is both even and odd. So the function given to you is not 0, it's not, it cannot be both even or odd. Okay. Any questions? Any questions about that? So this is just some, algebraic manipulation. You can write it down and think about it, think about the process. If you have questions, and come back to me. Okay, but next I really want to get to our trig functions. Okay, so let's get to our trig functions. Trig functions. Trig functions, even, odd, neither. Even, odd, or neither. Or neither. Okay. Let's start with sine. Let's start with sine. I also want to use this opportunity to review ARD. So by this time, we have covered ARD how many times? Many, many times, right? Many times, right? There are two ways you can look at even odd properties. Okay. One is from the graph we already did, right? And the other one is from the unit circle. So let's look at the graph, because the graph is the most direct curve that reflects the relationship between input and output. And we spend so much time on it, right? We spend so much time on it. So I'm going to just bring the graph over. Right there. So this is the curve. This is the curve. Now, when we observe this function, is it even or odd? What do you do? What can you do? What can you do? Right? You have to first understand the definition. We have to first understand the definition, right? So where's the definition? I'm going to bring the definition right to the top. So you get to see the definition, right? If we don't know it's even or odd. So from the visual, what do we see? We certainly need to recognize f of x from what we just observed is x squared x to the power 3, right? And neither, we have 3 examples. We had 3 examples. So we're going to go by the definition. Input. That input is not visible enough. Okay, so I'm going to make it thicker, right? So suppose I have an input. That input is -2. And what's the opposite of -2? +2. And what's their output? The output for -2 is right here, right? The output for +2, they're over there. Even or odd? It's difficult to see how if the red are exactly the same, right? But we definitely did the graph, right? So this is x, and this is a -x. Are we sure these 2 red are? I should make these blue, but you guys understand what I'm doing here, right? In the ideal world, I should make this blue. opposite input, respective outputs. If the respective outputs are the same in every situation of this kind, then it is odd. But from this, what we saw, it's impossible for sine to be even. Do you guys agree with me? Is it possible for sine to be even? Not at all, right? Not at all. So sine may be odd. So next, I want you guys to work out a table. I want you guys to work out a table to see for yourself. To see for yourself. You ready? To work out this table, I also want to bring, I want you guys to use ARD, and I'm going to bring back my, my unit circle, right? To see how we can use this unit circle to observe the even or odd situation of the function. Okay, even or odd situation of the function. So what I, once again, so this will be a good practice because now we've been touching a lot. We'll be using a lot of the exercise we did in the past weeks about trig functions. So next, so this time I'm also going to be doing x negative x, but the function here we're going to have is f of x equals to sine x, right? And I'm going to give you some values and introduce you guys to some, ways that we use the function. And f of negative x equals to, right? F of negative x, you know what that is, right? So now I'm going to give you some concrete values. These concrete values will be pi over 6, right? Negative pi over 4. I want you to do it by ARD. I'm going to give you an example, okay? I will give you an example. Pi over 3. Okay, so this is going to be 3 pi over 4. Make it a negative. 5 pi over 4. And the next one would be negative 7 pi over 6. Okay, so I'm going to work a situation. I'm going to show you how I want you to work it. Okay, using ARD. Okay, you will find that using ARD, you actually get your answer much faster. The first time you may just use, you need 5 minutes to go through the whole process. Oh, that's too slow. Well, the second time it take only two minutes. The third time you try it, it probably just take you 1 minute. And as you continue to use ARD, you will soon realize it takes you just a nanosecond because you're so used to that thought. So you guys have that sparks, 1, 2, 3, ARD. It works amazing, let me tell you. Okay, so the opposite of negative pi over 4 is pi over 4. I'm sorry, pi over 4. And we just put a negative sign in front of it. So the negative of negative pi over 4 is positive pi over 4. But this is reflecting, okay, this is a reflection of, even though you can see you get these angles, no problem, but it reflects whether you measure the angle counterclockwise or clockwise, right? So we look at that. So when we do f of negative pi over 4 versus we're doing f of pi over 4, right? F of pi over 4, that's a sine pi over 4. Right, I know you know the answer. I know you guys know the answer very quickly. But I want you guys to think the process, right? If I measure counterclockwise for the pi over 4, and this is the terminal, right? This is the terminal. If I look at the negative pi over 4, what do? You still measure from the same place, you end up here. And the answer you get is going to be the blue number. And the blue numbers are opposites. You guys see that? The blue numbers are opposites. You guys see that? So what do you get? So let's see. Oh, did I? Right? So sine of negative pi over 4, you measure clockwise, and the answer is going to be negative 1 over root 2. It doesn't matter, you use root 2 over 2 or, you know, 1 over root 2. It doesn't matter. And the other one is what? 1 over root 2. So what is the conclusion? What is the conclusion? When the input are opposite, the output are what? Opposites. So now we can kind of have some kind of guesses, right, about sine, yes? Yes, what would that be? How would you express it? F of negative pi over 4 is the same as f of pi over 4. Do you guys follow me? You use ARD to complete this process. You use ARD to complete the process. Okay, actually sometime in time, you're gonna see you get it done sooner. Of course, speed is not we're asking for, we're obsessed with, right? We're trying to train ourselves to do it in a certain way so that we can improve efficiency. We can improve efficiency and correctness, right? So now I want you guys to work out these other quantities in the table. Okay, we still have some time left, and Farouz is eager to help. So have one, sorry?
Professor, the notation you had for pi over 4 and negative pi over 4, conclusion is the sine is the odd function. Is that true?
Yep, sine is odd.
Yes.
Sine is odd, right?
Yes.
But we want to have a sense of it. We want to have the visual of it. We want to be able to do the algebra, to reflect the process. You guys will need to use the even odd function properties in chapter 5 of calculus 1. Okay, ready? So let's do the breakout room. I know you might be tired at this point. Okay, I'm going to give you guys just, how about like 7-8 minutes so we can wrap up together, right? Yes? Ready? Let's go. Measure your angle, okay? Measure your angle. Go through that, clockwise, counterclockwise process. And you're going to discover some more interesting features about the unit circle. There's a wealth of information we can explore. Okay, there's a wealth of information we could explore. I have assigned you homework to do similar things. You guys have the table, right? You guys have the table. I just want to mark something on the graph before the closure of today's class. Okay, let's do this. All right, guys, I hope I didn't close the room too soon because I want to give you a closure for today's work. And I also have assigned you some work on for the homework, okay? I trust you guys know how to do these, okay? If you have any questions, we will certainly continue tomorrow on this topic. So primarily you can see that, you know, whenever the inputs are opposite, right? In this setting, it involves ARD, right? Because positive angle is counterclockwise, negative angle is clockwise. So when we measure the angles, you know, either way, your terminal and the output, you can see that from the perspective of the unit circle, you can also see this more straightforwardly from the curve itself, because the curve itself, as we work so hard to get, right? We have the arc length, right? And we have the input, and we have the output. So whenever the inputs are opposites, their respective outputs are opposite as well. So that confirms that sine is what? Is an odd function. It's an odd function. For odd function in integration, in the section of integration, you have some interesting properties. Okay, chapter 5 of calculus 1. And for even function, which is we have 6 minutes left, right? And I'm not completing the table for you in class, right? I'm not completing the table for you on class. I want you guys to, I trust you guys have completed, okay? If you have any questions, please ask now. If you guys have any question completing the table, I trust that you guys have got it, right?
Professor, can we complete -7 pi/6 or we don't have time?
Oh, we can do that.
Thank you.
-7 pi/6. Okay, so when we work with -7 pi/6, what we can do, okay, -7 pi/6, right? So you would, of course, the opposite of it is 7 pi/6. Is 7 pi/6. So when we do -7 pi/6, we're going to measure from the standard position, of course, right? That's how angles are measured. And then we go clockwise. So this is a pi. And plus another pi/6, this is the terminal of a -7 pi/6. Because if you do a fraction, right? 7 pi/6 is equals to what? If you split it, 6 pi plus 1 pi divided by 6, you're going to end up with a pi plus pi/6. So that's how that helps with the measurement, right? So it terminates here. So what is 7? What is sine -7 pi/6? It's a positive half. It's a positive half, right? How about we measure positive 7 pi/6? You're going to measure counterclockwise, and you're going to end up here. You guys see that? And the sine value of that is a -1/2. So -1/2 and +1/2, they're opposite to each other. They're opposite to each other. Do you guys see that? And how do we express it? How do we express it, right? In a lot of situations that mathematics, you understand, you have to know how to express it properly. How to express it properly, okay? You're going to see variety of expressions. You have to be exposing yourself to variety of expressions. So when we have f of -7 pi/6, which we just did, right? It ends up in the second quadrant. And that's going to give us what? Sine of -7 pi/6, right? When we are doing ARD, what do we get? We get a 1/2. And the other one, f of negative x, because the opposite of negative 7 pi over 6 is f of what? It's f of 7 pi over 6. 7 pi over 6, okay? And that equals to what? That equals to sine of 7 pi over 6. Sine of 7 pi over 6, it terminates in the third quadrant, which we just saw, and that equals to -1/2. You see how much information we can dig out from this simple unit circle, right? And obviously in this case, it is also true, f of negative 7 pi over 6 is a negative, is the opposite of, oh geez, let me copy this, right? It's the opposite of that. So whenever the inputs are opposite, their respective outputs are opposite as well. Doesn't that confirm the sign? Well, this just confirmed, it's not a proof, okay? This is not a proof. It confirms that sine is what? Sine function is an odd function. Okay, and in the process, we get familiar with the notation, right? We get to review ARD, and I hope this helps you. I hope this helps you. Any other questions? Do you want me to complete the rest of them, or you guys got it?
If we have time, as a practice makes it perfect,
Yeah,
maybe
so
one more.
did you guys have a hard time with it? Yeah, so let's do it. I'm going to take a little bit more of your time, okay? But it's going to be all in the recording. If you have to go, you can go, right? So the opposite of a negative 3 pi over 4, you just put the negative sign in front of it. So that's going to be 3 pi over 4, right? 3 pi over 4, if you measure the angle, right? You can, I think I want you guys to see why I emphasize ARD. I hope by this time you guys really understand ARD. ARD is the 3 pillars of trigonometry. Okay, so 3 pi over 4, negative 3 pi over 4. Negative 3 pi over 4 will be an angle measured clockwise from here. Whoopsie, sorry. Okay, it's an angle measured clockwise. It terminates in the third quadrant. So you see the two blue numbers, they're still opposite to each other. Do you guys see that? Yeah? Okay, so sine, right? So I'm using these notations. I introduce you guys to these notations, right? You guys are going to see these notations a lot. So negative 3 pi over 4, that's going to give us a negative 1 over root 2. Okay, and f of 3 pi over 4. You guys have homework, okay? Today's homework, I basically made it you know, outside the notes, because when I was creating the notes at the time, I didn't think of these exercises, but as I go over these contents, I realized and these exercises will be very helpful for you guys to understand even odd function, so that you can, you know, once you're doing that calculus class in chapter 5, you have a good visual about what we're doing here. Okay. And for 5 pi over 4 is similar, right? So let's look at the measurement for 5 pi over 4. For 5 pi over 4, the measurement would be, you know, hold on, let me clean this up. Right, 5 pi over 4, negative 5 pi over 4, right? How do you measure it? 5 pi over 4 is going to be here. It terminates in the third quadrant. Negative 5 pi over 4, you measure from the same place. Negative 5 pi over 4, you ended up here, right? Right? So how do you break up those? How do you break those into? You know, you need to know how to break those. Say for 5 pi over 4, right? 5 pi over 4. These are the fractions you need to be able to how to handle, right? So what you do is you just split it. 5 pi, it's just for convenience, really, because it helps you to measure. It helps you to measure, right? And now we have a 4 pi plus pi is 5 pi. 5 pi is, you know, we have 5 pi over 4. So we take the 4, divide into each, so we get a pi plus pi over 4. Right? So this will make the measurement so much easier. And as a result, right? So we have a negative 5 pi over 4. After you've done these things and all these angles is no, all these ARDs, you have no choice but to be very good at this by now. So that's going to be sine of 5 pi over 4. Right, that ends in the third quadrant, and it's going to give you a negative of 1 over root 2. Right, and the other one, f of negative 5 pi over 4. Right, you measure the angle clockwise, so you have sine of that negative 5 pi over 4, you put it right here, and the terminal is in the second quadrant, and you're going to get 1 over root 2, right? And once again, we observe that f of negative 5 pi over 4 is the same as f of 5 pi over 4. Right? So each case we're working with, we saw clearly whenever the inputs are opposites, their respective outputs are opposite as well.
And that's the definition of odd function.
That's the definition of odd function. And that, of course, has to be true for any point, any inputs. Okay, we just enumerate a couple of them. This is not a proof. This is just a confirmation. This is a confirmation or verifying. Verifying can never replace the proof, right? I saved the easiest for last. Do you guys get this one? So this is a negative pi over 6, right? This would be pretty easy for you, right? So f of pi over 6 equals to sine of pi over 6. You guys need to practice writing these notations, okay? I cannot go to your house to check on you, but if you just practice writing these notations, and you're gonna get points. You're gonna get points. May not be in this class that much. You're gonna get a lot of points in the next class. You guys with me? So let me quickly just finish this, and this is gonna be negative. And this is going to be negative, and this is going to be negative. So once again, we have demonstrated whenever the inputs are opposite, their respective outputs are opposites as well. Okay, that's what is odd function is about. Okay.
Professor, I will be
Yes.
in the Math Study Center today from 3 to 6 p.m. If anybody interested, they can join me and get more help.
Of course, great. Thank you so much. Okay, I'm
You're
sorry I
welcome.
take more time. I will see you guys tomorrow,
Thank you very much, Professor, for the lecture.
of course. I'll see you guys tomorrow.